Hello and welcome to the video for 5.6, graphing linear inequalities in two variables. We're going to start off by putting our name, date, and then we're going to say 5.6, or we can say section 5.6, which is going to be, I'm going to write the title on the top, graphing linear inequalities. All right, so a couple things you want to have here. You want to make sure that you have some graph paper to put these things on. I like to use highlighters for some of the shading regions. You don't have to, but it definitely makes it easier. So if you have highlighters, use those as well. All right, and then we're going to fold our paper into hot dog and hamburger. All right, so we want to do that. We're going to have 5 graphs we're going to do as a class, and then you're going to have one for you try for homework. All right, so I want to start off with some steps. Okay, so I'm going to say steps for graphing linear inequalities in two variables. All right, the two variables thing is just basically telling us that we're going to have an x and y in each of these equations. All right, so step 1, we're going to use these top 2 boxes here, is going to be get the inequality into slope intercept form. Sorry, I need to. All right, which is going to be y equals mx plus b. Okay, remember that slope intercept form, just to remind us. All right, step 2 is we're going to use a dashed / dotted line with greater than or less than. So just remember, we're going to have lines that will look like this. Right? And we're going to use a solid line with greater than or equal to or less than or equal to. All right, any more normal lines we would have here. All right, I remember that if it has the line underneath it, it's a line. If it's missing the line underneath it, it's missing parts of the line. All right, so that might be helpful. All right, step 3, all right, is we're going to pick a test point. I like to call that a TP for test point that is not on the line to determine where to shade. All right, and then step 4, we're going to have 2 parts here. If the test point is true, shade that side of the line. If the test point is not true, shade the opposite side of the line. Okay, we'll kind of get through this. All right, just understand that we actually have infinite solutions for these things. So we want to make sure that we do pick a test point and know exactly where we're going to shade. And that shading part's going to come into our highlighters. All right, so we have our first 2 graphs I've already drawn here. If you need to pause the video, that's totally fine. All right, so the directions are basically just going to be the graph here. All right. And I'll just say graph the inequality. All right, so number 1 is going to be y is greater than 2x plus 1. Okay, so when we have this, I like to go through and notice it's already in slope-intercept form, which is great. Our slope is 2 over 1. Our b is 1. All right, and because this is just greater than, this is going to tell me it's going to be a dashed line. Okay, and if you want to say dotted, that's fine. Okay, so I'm going to go through and graph this just like I normally would. All right, I'm going to start at 1. My slope is up 2 over 1, or down 2 left 1. Okay, and then I'm going to take a ruler or a straight edge here, and I'm going to graph my line. Remember, it's dotted, so I'm just going to kind of skip some spots on my line. All right, so there's my equation, my inequality of this one right here. Okay, now what we're going to do is we're going to pick a test point, right? I always like to, if I can, to pick a test point that it would be 0, 0. Okay, so my test point is the origin here, right? And I know it's hard to see, but it's right there. So I'm going to plug that into the inequality. So 0, 2 times 0 plus 1. So I'm going to say, is 0 greater than 1? This is not true. Okay, so I'm going to shade the opposite region. So I'm going to shade everything above the line, okay? Not including points on the line, like I just kind of highlighted by accident, all right? But everything above the line is a solution to this inequality, all right? When it's a dotted line, it should not be highlighted. I just made a mistake here when I was trying to draw a straight line, okay? All right, so example 2, we now have y is less than or equal to negative x plus 2. Okay, awesome. Another equation is already in slope-intercept form. So our slope is negative 1 over 1. Our y-intercept is 2, so that'll be 0, 2. And this is going to be a solid line. Okay, and that's just because it's less than or equal to. So we go through, we start at 2. All right, our slope is negative 1 over 1, so I'm going to go down 1, right 1. I'm going to kind of do that as many times as it fits on my graph. All right, and now I'm going to draw my line. All right, so now I'm going to go through and pick my test point, which is great. I'm going to pick 0, 0 as my test point again. And now I'm going to plug it in. And now this is going to be, is 0 less than or equal to 2? In this case, this is true. Okay. So I'm going to shade the area that the test point is. In this case, it's below the line. So everything below our line is a solution to this inequality. And I could even keep going over here. I just don't want to have to color my entire graph, okay? All right, so now when we flip our paper over, we got, all right, 4 more graphs to go through. All right, sorry, I just want something underneath to write on this thing. So number 3, is going to be negative x plus y is greater than or equal to negative 4. Okay, now notice for this one, it's not in slope-intercept form. So that's the first thing we need to do here. So I'm going to add the x to each side, and that's going to leave me with y is greater than or equal to... All right, so I'm going to add the x to each side, like you can see here, to get it in slope-intercept form. I'd have y is greater than or equal to x minus 4. My slope is the number in front of the x, which is 1 over 1. And my b is negative 4, which would be 0, negative 4. Right? This is a equal to, so this is going to be a solid line. All right, so if I start off at -4, 1, 2, 3, 4, my slope is up 1 over 1. All right, I have these things. It's a solid line. So I'm going to graph those, or connect those points. All right, and now, once again, I need to pick my test point. My test point, I always like to pick 0, 0. You don't have to, it just makes our life a lot easier. You can pick any point you want as long as it's not on the line. All right, so if I plug it into the original, I would say negative. What I'm now gonna do is I'm gonna pick my test point, which is 0, 0, and I'm gonna plug it into the original equation. Now understand, we can pick any point on our graph as long as it's not on the line. All right, so -0 plus 0 is greater than -4. This would be 0. Now this one can be tricky. Is 0 greater than -4? Yes, it is, right? So this is true. So we're gonna shade this entire region. We're gonna shade everywhere above our graph. Okay. All right, hopefully you can see that yellow highlighter. I think you should be able to. If not, I'll just use blue from now on. You can see we're gonna shade everywhere above our line, okay? All right. Number 4. All right, number 4, we have -x plus 2y is less than 2. All right, so we have some work to get this one into slope-intercept form. Our first step is we're gonna add the x. So we'd have 2y is less than x plus 2. Now we need to get the y by itself, so we're gonna divide everything by 2, and our equation will be 1/2 x plus 1. Okay, I'm gonna write all of my information over here this time. My slope is 1/2. My b is 1, which is 0, 1. And now notice again, this is a dashed line, right? Because it's just less than. Okay. So if we start at 0, 1, our slope is 1/2, so we're gonna go up 1 over 2. We're gonna rise 1, run 2. All right, or we can fall 1, run 2, fall 1, run 2. All right, and just remember that this is a dashed line. So we do it, we only want to make pieces of our line, not the whole line, okay? Now, for some reason, if you're doing it and you forget and all of a sudden at the end you're like, oh, that should have been a dashed line, just make a note and let us know that it should have been a dashed line, okay? All right, so now we need to pick our test point. Once again, it's great that our test point, we can use 0, 0 again. So we'd say -0 plus 2 times 0 is less than 2. All right, 0 plus 0 is less than. All right, so when we pick our test point here, it's nice we can pick 0, 0 again. All right, we do -0 plus 2 times 0 is less than 2. So we'd have 0 plus 0 is less than 2. All right, is 0 less than 2? Yep, this is true. So once again, because it's true, we're gonna shade where the test point is, which is in this case, is below our line. All right, so we're gonna shade everywhere down here, right? We can even shade all the way down here. Okay, all right. Last one we're gonna do on together, and then you're gonna have one that you're gonna try on your own. Okay, number 5. Is going to be x plus 4y is going to be greater than 12. Okay, so what we need to do is get this into slope-intercept form. So we subtract x. Right, we have this 4 out in front, so we're going to divide everything by 4. So our inequality is going to be negative 1/4 x plus 3. Okay, so our slope is negative 1/4. Our y-intercept is 3. And we know this is going to be, oh, it's just a greater than, so this is going to be a dashed line. We can tell all that just from the inequalities and our information we gathered. So we're going to start at 3. All right, our slope is negative 1/4, so we're going to go down 1, right 4, or up 1, left 4. All right, sorry, it's going to kind of go through my work here, but we're going to use a dotted line because it's going to be a dashed line here. All right, I'm just going to kind of cut this one short here so you can kind of see it. I don't want to mess up in case you missed a part of it. All right, so now once again, what we need to do is pick our test point, which is 0, 0. Now we'd say 0 plus 4 times 0 is greater than 12. Is 0 greater than 12? No, this is not true. Or we can also say it is false. So we're going to shade the opposite area or the opposite region. So this point's below, so we're really going to shade everything above our line. Okay. All right, so the last one is going to be a U try. All right, and it's going to be negative 6x plus 3y is less than or equal to negative 9. Okay. Please let us know if you have any questions. We'll see you tomorrow. Have a great night.